quadratics and invertible functions. The learning targets for this lesson are going to be determine the inverse of a quadratic function, determine the domain and range of for a quadratic function, and how to restrict the domain so we can create a function that we call invertible. So that's going to be a new term we look at in this video. So to start off with an example, so this again is a quadratic. So this is something you spend quite a bit of time working with in Math 2. And characteristics that you always want to make sure you remember for a quadratic. So we have this function here. It's in that vertex form. So the highest or lowest point, or our maximum or minimum, is always referred to as our vertex. So for this problem, you can see that our vertex is going to be -2, -4. So that's our lowest point for this problem. Something else you might remember from Math 2 is talking about domain and range. So domain is considered all of our possible x values we can have for a function. So in this case, our domain is really going to be all real numbers. So any number I substitute in for x, I'll get some answer back out for y. So our domain for all quadratics that are in this form is going to be all real numbers, or -infinity to +infinity. Our range, when we talk about a quadratic, is obviously not going to be all of infinity, because it does have a max or a min. And so an easy way to kind of think of a range for a quadratic, our vertex is in the form of h comma k. So our domain, when we're working with a quadratic like this, is always all real numbers, and then our range is always going to have something to do with our k value for these, right? Before we start doing anything with inverses. So our range, if it opens up, is going to be that k value to +infinity, or if it opens down, it's going to be -infinity to that k value. And that's always going to be true for these problems if they're before we start inverting and doing anything like that. So for this problem, our range goes to our -4, which again is our k value, and it's going upwards to +infinity. In part C, we're going to write the equation for the inverse of f of x. So for this problem, we have f of x equals x plus 2 squared minus 4. And we're going to solve this the same way we did our other inverses. So we're going to replace the f of x with a y, and we're going to swap the x and the y. So I'm going to go ahead and swap those out. So now we end up having here x equals y plus 2 squared minus 4. And now we're going to solve this so our y value is by itself. We're going to add 4. We're then going to square root. And we technically do have a plus or minus there. We kind of skipped over that in one of the other videos a little bit, where we didn't write that plus or minus, but it is going to kind of come up a little bit when we start talking about inverses and what functions can have an inverse, and if there's anything we end up having to change. So I'm actually going to write that plus or minus. And if I rewrite this now, it might look something like this. So y equals plus or minus x plus 4 minus 2. And so this would be the equation of our inverse. In part D, we're going to be completing our table and graphing it. We're going to talk about what this inverse looks like, and if the inverse is going to be considered what we call a function. So reading this off the graph, you can see -4, we would have a value of 0. At -3, we would have a value of -3. At -2, we'd have a value of -4. and then the values then repeat themselves. So when we do the inverse, we're really taking those x and y values and just flipping them around. So if one of them has the point -4, 0, we then have the inverse would have the point 0, -4, then -3, -3, -4, -2, -3, -1, and then 0 and 0. And now we're going to go ahead and graph this out. So we have here 0, -4, which would be right here. -3, -3, -4, 2, -2, and then those values would repeat themselves. So the graph would look something like this, where it's the parabola that's on its side. For part E, the question asks, for an equation to be a function, there must be one x value for every y value. So what that means is that it actually has to pass what we call the vertical line test that you might remember from Math 1 and Math 2. And so what that means is if I draw a vertical line, that line should only intersect the graph at one point. So if I was to draw these vertical lines, you actually can see, like this one right here, actually would intersect at 2 different points. Same thing for any other vertical line we drew. So what that means is f of x is actually, is it a function? No, because it's not a function, because there's more than one output for an input. So for example, when x is 4, I get 2 different y values, which would make it not a function. So no, because it failed the vertical line test. The last part then says a function f of x is invertible if the inverse is a function. Is f of x plus 2 quantity squared plus 1 invertible? So this was our function. This is the graph of the inverse. And the answer is no, it's not invertible, because f of negative, or the inverse of f of x, is not a function. And that's because, again, the inverse is not a function. So this leads us to our definition that we're going to see come up in this section and the next section. Is talking about, again, an invertible function. So an invertible function is a function where the inverse also creates a function. Another big piece we're going to see is that although some functions are not invertible, we can actually restrict the domain of a function to create an inverse that is invertible. So for example, the one we just did, which was this f of x right here, the domain was all real numbers. The range was -4 to infinity. That one was a function. But when we, actually took the inverse using a chart or a table, we found that we got something that was not a function. It failed that vertical line test. Right? But another way a way we can get around that is if we take a function and maybe only graph part of that function or restrict the domain. So instead of making our domain all real numbers, I can make my domain simply go from the vertex to maybe all the x values on to the right of the vertex. I could have also chosen the other half as well. And so this is still a function, but now if I was to invert it, I would get something that is a function. So this new inverse, that's really just the same as this, but I only used like the top part of it. if I did the vertical line test, it would actually now pass the vertical line test, and it would be considered a function. In example 2, we're going to look at how do we restrict the domain so that we can make a function that's invertible, and then we're going to sketch the inverse using our restricted domain. So when we look at this, we can tell that this quadratic is, if we were to create the inverse would not be a function, right? It would be on its side like the last example. So what we're going to do is we're going to select part of this parabola. So I'm going to start from the vertex and maybe just focus on maybe just the right part. I could have also done the left part if I wanted to. So if I'm only focusing on the part I marked in red, so that just half of that parabola, my domain is no longer going to be all real numbers. So my domain, you can see now, is going to start at -3. And it's going to continue to all the positive numbers, or all the numbers that are to the right of that. So it's going to go in a positive direction. My range is going to be very similar to how I did range before I restricted the domain. It didn't ask for the range, but we're just going to write it just to have it. So you can see our range is going to start with a +1 and again go to positive infinity. If the question asked to sketch the graph, what this will look like, a way that we could sketch this graph is first we can make a table if we're not sure how to graph it. So if I make an XY table, I might use a few points here. So I have the point -3, 1. I have the point -2, 2. I have a point in here 3, 5. Those might be the only points I see right now. And then if I want to write the inverse, so if this is f of x, I'm going to do the inverse just by flipping those points. So 1, -3, 2, -2, 5, and 3. And then I can just simply plot those points, and that would help me do the sketch. All right, and then that would be what the sketch of the inverse would look like. For example 3, the question says restrict the domain f of x so its inverse is a function, and then write the equation of the inverse. So for this one, same thing, we can tell that this is going to end up being a parabola or a quadratic because it's got that x squared there. And so when we go ahead and look at this, a lot of different ways that we can figure out how to sketch this out. But what we do know is that our vertex here, if it's in that vertex form, that we remember from Math 2 is going to be 2, -9. And kind of like we saw in the last example, we're going to, if we're looking at this parabola, and I'm going to maybe just draw kind of a rough sketch here. And then I got 2, I got 9. I know it's going to be opening up. This is, again, not the best sketch, but kind of a rough sketch here. We know we're just going to focus on just half of this parabola. So maybe like this half right here. Okay, so if I was to look at this domain, I'm going to start the x value of my domain with the x value of the vertex. And I'm going to choose just the right side, so it's positive, but you could have done -infinity to 2. That would still get you a correct answer. For the range, I'm going to start, I know my vertex, this is -9, so I'm going to go from -9 to infinity. It didn't ask for the range, but we'll just write it just cause. And so those, again, you can see actually come from the vertex. And again, I'm using that vertex form that you guys did in Math 1, or I'm sorry, Math 2, which is that ax squared, or ax minus h squared plus k. And so the question now says write the inverse. So we're really just doing the inverse over this domain. So we don't have to, when we solve it, do the plus or minus like we did last time, because I'm making it so it's the inverse is a function. So when I go ahead and write this now, I'm just going to flip it around. I'm going to write it so these are flipped. I'm going to change that f of x to a y. And then just simply solve for y like we usually do. Now, when we square root, we don't have to include now the plus or minus because we restricted the domain that we're not going to have any values that are going to be to the left side of the vertex. So I'm going to keep this as a plus now. I don't need to do the plus or minus anymore. I'm going to add 2. And so my inverse is now going to be 2 plus x plus 9, or square root of x plus 9 plus 2. Either one works. And then that would be my inverse. If you have any questions, you can sign up for T-Bolt time, get help from the center, or ask for help during class.